Okay, so this video today is going to be all about molarity and calculating molarity. But before we talk about molarity, I want to talk about orange juice, specifically frozen orange juice. You know, the frozen orange juice in the can, the frozen orange juice concentrate, and you add water to it to make orange juice. So let's take a look at this recipe for orange juice. We have 1 can of the frozen orange juice concentrate, and then you put in 1 liter of water. So that's going to be 1 can per 1 liter of water. So you could say that this orange juice, when you make it in the pitcher, this orange juice has a 1 can per 1 liter of water ratio or concentration. So you could say that this has a molarity of 1 molarity, which is 1 can per 1 liter. Because molarity is however much of something you put into it, in this case, 1 can, out of 1 liter. This 1 liter never changes. It's always in 1 liter is what the molarity is. It's the ratio of however much you put into the 1 liter of water. So you could have 1 can of orange juice in 1 liter of water. You could have 1 mole of salt in 1 liter of water. You could have 1 mole of hydrochloric acid in 1 liter of water. It's just the point is that it's always molarity is always talking about however much of something you put into 1 liter of water. So in this case, we're going to put 1 can of frozen orange juice concentrate into 1 liter of water. So that can be said to have a 1 molarity, and molarity is a capital M. So 1 molarity, or we could call it 1 canarity, just to be silly. 1 canarity, since we're talking about cans, we're not talking about moles. But it's the same concept. You have 1 can of frozen orange juice concentrate, of the concentrated stuff, in 1 liter of water. So that's going to be 1 molarity. But what if you didn't want that orange juice that strong? What if you wanted it diluted, doubly diluted? So you put in 1 can of orange juice and you put it into 2 liters of water. 2 liters of water. Okay, this is no longer a molarity of 1 because molarity is all about the 1 liter. But in this recipe, we're using 2 liters. So how do we find the molarity? Well, we have 1 can in 2 liters of water, but we need to find out how many cans would be in 1 liter of water if we used this recipe. So we put 1 can of orange juice, but we put 2 liters of water in it because we like our orange juice kind of diluted. So that's going to give us only half a can of orange juice per every 1 liter of water because we put a whole can in 2 liters of orange juice. So half is the same thing as 0.5 if you know your decimals. So it's going to be 0.5 cans in 1 liter of water. So this molarity would be 0.5. Okay, so what if we wanted our orange juice even more dilute than that? and we put 1 can of orange juice into 3 liters of water. So we want it really, really dilute. We like the water part of it. So we want really dilute orange juice. 1 can of 3 liters of water. Well, to find the molarity, we need to find out how many cans of frozen orange juice is that when you break it down per liter. So if you look and see that 3, if we break 3 down into 1, that means we have to divide by 3, because 3 divided by 3 is 1. So 3 liters divided by 1 liter is 3. So here's our divisor, is 3. So if you want to find out how many cans is in 1 liter, you also have to divide this can by 3. So that gives us 1/3 of a can in 1 liter. And 1/3 in your decimal form is the same as 0.33. So the molarity of the orange juice, if you use 1 can and add 3 liters of water to it, is going to be 0.33 molarity. Now, what if we like our orange juice really strong and we put in 1 can of orange juice and we only put in half a liter, so that's 0.5 liters. If we only put in half a liter, what's the molarity for that? Well, the molarity is how many cans we would put in 1 liter. Even if we didn't make a whole liter of orange juice, it's just theoretically, if you were to make a whole 1 liter of orange juice, how many cans total would you need for that liter of orange juice if you put in 1 can for every half a liter? So a half a liter goes into 1 liter 2 times. So 2 times. So this factor, this times 2, is what you're going to need to bring up and multiply by the cans, times 2. So 1 can times 2 is 2 cans. So if you use 1 can of orange juice and you only put in half a liter of water because you like your orange juice strong, that means if you needed to make a whole liter of orange juice, you would need 2 cans of the orange juice concentrate. So that means the molarity is 2. So now, what if you want to make this orange juice really, really diluted, and you put 1 can in 10 liters of water? What is the molarity there? Well, the molarity is always how much of that orange juice is going to be present in only 1 liter of water. Again, molarity is all about 1 liter of water. This never changes. It's always out of 1 liter of water. So we can't say the molarity is 1 because we put 1 can in 10 liters of water. So that's going to be way more dilute. So we need to find out how much of that can of orange juice concentrate is in 1 liter of water. Well, we have this 10 liters of water that we put in. To bring this down, if we're just going to pour out 1 liter of this 10 liters of dilute orange juice that we made, that's going to be a tenth. That's going to be 1/10 of the original amount of the 10 liters of water. So we can take this 1 can times 1/10, and that's going to equal 1/10 of a can, or 0.1 cans in 1 liter of water. So the molarity would be 0.1. Here's where it gets a little bit tricky. Or it doesn't get tricky, it just takes more math to solve. So what if we put 0.5 cans, half a can of orange juice in 1 liter. So that gives us a 0.5 molarity. But we have, our niece comes over and she likes the orange juice more diluted. So she wants the orange juice diluted to a 1/10 molarity, 1/10 molarity. So how are we going to do that if we have a 0.5 molarity of orange juice, if we have half a can per liter of orange juice? How do we dilute that down so it's 0.1 cans in 1 liter? Because remember now, 0.1 molarity means 0.1 cans in 1 liter. But we start out with 0.5 cans of 1 liter. So we start out with 0.5 cans of a liter of orange juice, and we need to make this 0.1 cans of orange juice in 1 liter. So how are we going to do that? We're going to take the formula of the concentration, which is the molarity, that you start out with, which is the 0.5, times the volume, which is the 1 liter, and that's going to equal the new concentration, which is 0.1, times the new volume, which we don't know what that is yet. So the original concentration you had was 0.5 molarity, and the original volume you had was 1 liter. But your niece comes over and she wants the orange juice diluted down to a 0.1 molarity. So how much water do you need to add in order to get the 0.1 molarity? So if we take 0.5 times 1 to equal 0.1 times question mark, first we can do this math. 0.5 times 1 is 0.5, and then we still have 0.1 times question mark. Then we need to isolate that question mark on one side of the equals sign to find out how much volume this is going to take. So we're going to divide both sides by the 0.1. These cancel each other out, and 0.5 divided by 0.1 is 5. So that is going to be 5 liters. 5 equals that many liters. So that means you're going to have to take your orange juice you made with a 0.5 molarity, that's half a can in 1 liter, and you're going to have to make that 1 liter. You're going to have to take that orange juice, which was made with half a can and 1 liter of water, and you're going to have to add enough water to make 5 liters of orange juice. But you still have that half a can, you still have that 0.5 cans in the orange juice, but you've added enough water to make 5 liters, and you just diluted it down. So you made more orange juice. So now you have 0.5 cans, half a can, in 5 liters of water. And if you boil that down to 1 liter, because molarity is always about 1 liter, if you boil that down to 1 liter, this 5 liters divided by 1 liter is 5. Then if you take this 0.5 of a can and divide it by 5, then you're going to end up with 0.1 cans in 1 liter of water if you dilute that down. So now you have your 0.1 molarity for your niece that came over that likes more diluted orange juice than you do. Now what if you make orange juice for yourself at home and you put in 1 can of orange juice in 1 liter of water? So that's 1 molarity of orange juice. But you drink half of it. So now you only have 0.5 liters of a 1 molarity solution of orange juice. And then your niece comes over and says she wants her orange juice diluted to a 1/10 molarity. So she wants that 1 molarity turned into 1/10 molarity. Well, you have 0.5 liters left of 1 molarity of orange juice. So you have 1 molarity of orange juice and you have 0.5 liters left. And she wants that 1/10 molarity. How much water do you need to add to that half a pitcher of orange juice in order to dilute it enough for your niece? So we need to bring this 1 molarity to 0.1 molarity. And 1 molarity, remember, is 1 can per 1 liter of orange juice. And we need to turn this into 0.1 cans of orange juice per 1 liter of water. So if we divide this 1 divided by 1/10, we're going to get 10, because 10 times 1/10 equals 1. So if we divide this by 10, we're going to get 0.1. So that means you're going to take however much orange juice you have, which is 0.5 liters, and you're going to multiply it by 10. And that's going to give you 5 liters. So you need to fill up your pitcher of orange juice until you get to 5 liters you need to fill up your pitcher of orange juice with water until you get to 5 liters. And that's going to give you a 0.1 molarity. Because check this out. Because if you have 0.5 cans and you have 0.5 liters, and you take this times 10 and you turn this into 5 liters, now you have 5 liters of water, but you still have 0.5 cans of orange juice in the solution. So 0.5 divided by 5 liters is 0.1. So that's going to be your concentration, 0.1 molarity. So now if you don't understand that, don't worry, we'll go back to it. But I want to return back to just basic calculating the molarity here. What if you have a 0.5 molarity, but you only have 400 milliliters of orange juice left because you drank the rest of it? but it's a 0.5 molarity. How many cans of the concentrate orange juice would be in that 400 milliliters of orange juice solution that you have? So a 0.5 molarity, a 0.5 molarity, once again, just means 0.5 cans in 1 liter of water. Okay, so that's the 0.5 molarity. But you don't have 1 liter of orange juice solution anymore. You drank a lot of it, so you only have 400 milliliters of orange juice left. And we want to know how much of the frozen orange juice concentrate can is in that 400 milliliters. Well, first we have to look at this. We have 1 liter here and we have 400 milliliters here. So we need to change this 400 milliliters into liters. So 400 milliliters is the same thing as saying 0.4 liters. Okay, so now we have 0.5 cans in 1 liter of orange juice, but we don't have a whole liter of orange juice. We have 0.4 liters of orange juice. So how many cans of frozen orange juice concentrate is in that 0.4 liters of orange juice? Well, we're going to look and see that if you take 1 liter and turn it into only 0.4 liters, then that is dividing the 1 liter by 2.5. So your divisor is 2.5. If you take the 1 liter of orange juice that you started with and you divide it by 2.5, you're going to get 0.4 liters. So we're just going to take that same divisor number and we're going to apply it up here to how many cans you have. So you started out with 0.5 cans in 1 liter, and we're going to divide that by 2.5. So 0.5 divided by 2.5 is 0.2. So you're going to have 0.2 cans in 0.4 liters of water if you still have a 0.5 molarity. Okay, let's try another one. So say you have orange juice, which is a 2 molarity, and you only have 750 milliliters of the orange juice left because you drank some. So how many cans of the frozen orange juice concentrate are in the 750 milliliters of orange juice if you want it to be 2 molarity? So again, 2 molarity just means that you put 2 cans of frozen orange juice concentrate in 1 liter of water. So that's a 2 molarity. So if you started with 2 cans of frozen orange juice concentrate in 1 liter of water, and you want to know how many cans are in 750 milliliters of water, well, first we need to change the 750 milliliters into liters because you have to have both liters on both sides of the equal sign. They can't be 1 liters and 1 milliliters. You got to have them both the same. So we're going to turn the 750 milliliters into 0.750 liters. So now you have 2 cans in 1 liter of orange juice, which means 2 molarity, but you only have 0.750 liters left of the orange juice. So how many cans of the frozen orange juice concentrate are in that 0.750 liters? So we're going to see how you turn this 1 liter into 0.750 liters. Well, you can divide it, the 1 liter, by 0.750 liters, and that gives you 1.333 as your divisor. So if you divide 1 by 1.333, you're going to get 0.750. So we can take that same divisor and apply it to these two cans up here. We can divide these two cans by 1.333, and 2 divided by 1.333 is 1.5 cans. So if you have a molarity of 2, meaning you made the orange juice with 2 cans of frozen orange juice concentrate and 1 liter of water, but you only have 0.750 liters left, out of that 0.750 liters, you're going to have a total of 1.5 cans of frozen orange juice concentrate. So that's going to be 1.5 cans. Okay, so let's try another one. Now you have a 5 molarity of orange juice, and you have 2,000 milliliters of the orange juice solution, and we want to know how many cans of frozen orange juice concentrate are in the 2,000 milliliters of orange juice. Well, how many cans did you make the orange juice with? A 5 molarity means you used 5 cans for every 1 liter of water. And you have 2,000 milliliters of the orange juice solution that you made. So you want to know how many cans do you put in that in 2,000 milliliters. Well, first we have to change these milliliters to liters so we're on the same page, and 2,000 milliliters equals 2 liters. So we have, if we have 5 cans for every 1 liter, because that's what 5 molarity means, if we have 5 cans for every 1 liter, we need to know how many cans are in 2 liters. Well, if you look at the liters down here, 1 liter turns into 2 liters if you multiply it by 2. So we're going to use that same multiplier times 2, and we're going to use it up here to the 5 cans. So 5 cans times 2 is 10 cans. So a 5 molarity solution of orange juice, but you have 2 liters of the orange juice, means you used 10 cans of frozen orange juice concentrate in the 2 liters of water. And that's still 5 molarity. It just means you have 2 liters of it. Now let's take a look at salt water for a minute. We have 1 liter of water. This is this H2O. We have 1 liter of water, 1 pitcher of a liter of water, and then we have 1 mole of salt. This is my attempt at drawing a salt shaker. So we have 1 mole of salt, and if we put 1 mole of salt in 1 liter of water, then we're going to get 1 mole, or 1 molarity rather, of salt water, because 1 molarity equals 1 mole of salt in 1 liter of water. So if we have a pitcher of 1 liter if we have a pitcher of 1 liter of water and we only have half a mole, here's my salt shaker, and we only have half a mole of salt. So here the salt's only filled up halfway into the salt shaker. So half a mole of salt. So we deal with decimals in chemistry, not fractions. So that's going to be 0.5 moles of salt. Then what's going to be the molarity if we put them together? In this pitcher of salt water, there's going to be a lot less salt, right? There's only going to be half the amount of salt. There's going to be 0.5 moles of salt in 1 liter of salt water. So that is going to equal 0.5 molarity, because that means you have 0.5 moles of salt still in 1 liter of water. So the liter didn't change. We still have the same amount of water. It's just what changed is we only put half the amount of salt in. So half is the same as 0.5. So our molarity is going to be 0.5 because there's 0.5 moles of salt in 1 liter of water. So if we have 1 mole of salt water in this top one, that just means that we have 1 mole of salt, which table salt is NaCl, sodium chloride, 1 mole of salt, and we put it in 1 liter of water. On this bottom one, we have 0.5 moles of salt water. So that just means we put 0.5 moles of salt in 1 liter of water. It's always 1 liter. So how do we find out how many grams of salt are in each of these pitchers? Well, for that, we're going to have to go to the periodic table. So we know that NaCl, sodium chloride, is table salt. So that means 1 mole of sodium and 1 mole of chloride. So let's go to the periodic table and look at that. Now, if you look to your left, Na, sodium, is all the way over on your left, and its atomic mass unit is 22.99. So if we take 22.99 grams of sodium, that's going to equal 1 mole of sodium. And if you look on your right on the periodic table, here's chlorine, and chlorine's atomic mass unit is 35.45. So if we take 35.45 grams of chlorine, that's going to equal 1 mole of chlorine. Now NaCl is 1 mole of sodium plus 1 mole of chlorine. So if we take the 22.99 grams of sodium plus the 35.45 grams of chlorine, we will end up with 58.44 grams of sodium chloride, and that is 1 mole of sodium chloride. So 58.44 grams is how many grams is in 1 mole of salt. So let's go back to our picture, and we'll put up at the top here our reminder, 58.44 grams of sodium chloride equals 1 mole of salt. And let's look at the first picture here. We have a 1 molarity of salt water. 1 molarity just means we put in 1 mole of salt for every 1 liter of water. So 1 mole of salt is 58.44 grams of salt. So in 1 molarity of salt water, we have 58.44 grams of sodium chloride every 1 liter of water. But what about down here in picture number 2? The molarity is only 0.5, which means you only put in half a mole or 0.5 moles of sodium chloride for every 1 liter of water. Well, so we're going to take that 0.5 moles and we're going to multiply it by that 58.44 grams, which is 1 mole of salt. And that's going to give you 29.22 grams. So in a pitcher of salt water that is a 0.5 molarity, you're going to have 29.22 grams of salt for every 1 liter of water that you put in.